I'd like to now talk about some epoxide reactions. We'll start with reaction of Grignard reagents. The Grignard reagent is treated like it was when we did the Grignard reactions with the carbonyl compounds. So the first thing we do is we draw the Grignard reagent and we take the MgBr off and we put the negative charge on the C to which the magnesium was attached. Then the negative comes in, forms a new bond with this C. These electrons go up on the oxygen. We get a negative charge here which adds to the H+, and we get our alcohol as a product. The reaction is summarized down here, and the red bond here is the new bond. And just like we did with the Grignard reaction on carbonyl groups, we get this new bond between the C from the Grignard that has a negative charge and the C which it attacked on the Grignard. I want you to take special note of the mechanism, how this is showing the formation of the red bond of a new bond, and then the only bond that breaks on the epoxide is the one attached to the O that breaks off here. The reason this is such a quick reaction is because epoxides are fairly strained. What you've got here is a 60-degree bond angles that really want to be something closer to 109.5. So there's a lot of strain in the ring here, so these open up fairly easily in this fashion. Alright, let's take another closer look at the mechanism. The other point that's important here is where the Grignard reagent attacks. So again, I'll just show you in action. We've got our Grignard reagent. The negative charge goes on this carbon. The electrons from that C attack this C here, and the electrons here jump up on the oxygen. The reason it attacks this side and not this side is because there's much more room on this side. So when we have Grignard reagents attacking epoxides, they always attack on the least hindered side, that is the side that has the most room around it, and that would be this one here, which just has two hydrogens attached to it. Right, there's the new bond, and there's our initial Grignard reagent right there. And you can see our epoxide has opened, and it always opens where the carbon was attacked. So the carbon that was attacked is where the ring will open on. And then we form our bond between the O- and the H+, and that gives us our alcohol product at the end. Now, the other thing I wanted to show you was the relationship between this and the Grignard addition to carbonyl groups. So if we use the same Grignard reagent and we were attacking a C double bond O, look what happens. I'm hoping you can see the similarity between the two. Now it's almost like this C double bond O is kind of like a ring in itself, except that the ring is really a double bond because it's attached to just one atom instead of two atoms like this one is. But you can see the similarity in the two mechanisms, and these are the kinds of similarities I really want you to take note of when you're seeing these kinds of situations. You put a negative charge on here once my pen responds. There we go. Alright, so hopefully you can see that.